All right, we've got the distinct, and I do mean distinct, pleasure of having a real live professor. Now, this is not to take away. Paul's a professor as well. He'll be speaking tomorrow, but you just have not heard a lecture until you heard John's. All right? So, okay, I could poke more fun at him, but I won't. So we'll just let him take. Now, he's got a very interesting talk here. He's going to tell us about his VSC-X and probably tell us what those letters stand for. So take it away, John.
Thanks, Steve. Hey, did you hear a little bit ago Larry Wolfgang talk about working at ARRL headquarters and having his first product review assignment be a HW, what was it, 3200? And I'm thinking to myself, yeah, 5400. I'm thinking to myself, you walk into work on Monday morning and they say to you, we'd like you to build this Heath kit this week. Where do you sign up for a job like that? It's incredible. Well, I've been working on this project now for a couple of years trying to find an appropriate radio. Here's the problem. You've got your mobile radio in your automobile, and it's got, some of them got 1,000 memories now. And you've got a computer in your house, and the radio is designed to be programmed by computer, because how else are you going to handle 1,000 memories in your computer plus all the other, or in your radio plus all the other settings? It's just not possible. And so your computer's in your house, and your radio's in your car, and you're about to go on a trip, and you want to put in some new repeater frequencies. Now, I don't know about you, but the radio in my car has 3 memories in use, because I had to sit in the car and program them. And I really wanted to make this more agile. I mean, the ARRL's got this disk out now with repeater directory by area of the country, and you can just load up where you're going, and it just would be really wonderful to be able to use tools like this. But in order to do that, you either have to take your laptop computer out to your car, or you have to bring your radio in and plug it in the house. And I don't know about you, but I don't do it very frequently. So I was thinking what I really needed to do was to solve this problem with a really long wire, because these radios generally all programmed by serial cable. But then I got to thinking about it, and I thought, well, I really don't want to run the wire out of my shack where my computer is, and down the hall and down the stairs and out the front door and across the yard and into the driveway and into my car. And what I'd really like to be able to do this is do this without a wire. And of course, the answer to anything that is without a wire is a radio. Now, but here's the problem. The radio is probably under the back seat in the car, maybe under the dashboard, and possibly in the trunk. And I don't know about you, my car is made out of metal. And so there's a shielding problem here as well. Now, those of you that were at the DCC 2 years ago saw me playing around with a thing called a Nordic radio. I was proceeding down this same road, and we walked around and took the thing out of the room, and the signal left. And it was clear to me that that wasn't going to make the nut. It just wasn't a powerful enough radio. And so I've been looking for digital radio modules now for a while that actually could manage this problem. And I think I actually finally found one. Now, this is a module that's now made by a company. It was originally put out by Maxstream. It's now made by a company called Digi. And this is the XB Pro module. It uses the Zigbee data communications protocol. Zigbee is pretty cool because Zigbee is capable of having self-organizing mesh networks. And I think that this thing is likely to be useful for a whole lot more things than just programming my radio, that is, in other applications. It seems to me you could get a little swarm of miniature robots with really bright lights on them and have them, like on a football field, self-organize into patterns. I just think this would make a tremendous halftime show. Because they don't have to all be able to talk back to a central controller. They're capable of relaying through each other and creating again, reorganizing, self-organizing mesh networks. All of that's wonderful. I have heard that this MaxStream product, now Digi product, does not fully conform to that Zigbee standard, but that's not a problem for me because I'm using it in a point-to-point communication application. The real thing here is that this radio is 50 milliwatts. And most of the little radio modules that you see out there on the market today that sell for, oh, I don't know, $10, $20, most of them are 1 or 2 milliwatts. I haven't seen any others that are 50 milliwatts. It's a 50 milliwatt digital radio data transceiver that quantity 1 costs $32. And I thought, okay, we're getting pretty close to what I'm looking for. Here were my design specifications when I started looking at this project. I need a data throughput that's compatible with most radio programming software, and that means at least 9600 baud. I don't want to fool with errors. The radio's got to take care of the errors for me. Again, I need transmitter power that's sufficient to handle 50 to 100 feet, but it's got to go into the trunk of a radio, or rather the trunk of a car. Some kind of, not a lot of data security, because I'm not really worried too much about somebody pulling up outside of my house and reprogramming my mobile radio. But maybe some data security. And the other thing I wanted was to be able to use this with a USB port on a computer, because more and more it's getting to the point where there aren't any serial ports. And here's another factor. The radios that we have today, some of them actually support RS-232 signals. That is, you plug it directly into the serial port on a computer. And some of them support TTL level signals. And I didn't want people to have to go out and buy those RS-232 to TTL level converters to use it. So it's got to be able to do both. And we're talking about hams here. So this project can't be more than about $100 or nobody's going to be interested in it. And so I found, I think, the radio that will do this. And it has worked very well. The range on it is quite impressive. I put one of these upstairs in my house, and I took another one 3 or 4 houses down the street and still was getting communication. I put one of these again upstairs in my house, and I took the other one out to my car, which was parked in my garage about 100 feet away, and I put it in the trunk and slammed the trunk shut, and I was still getting communication. So I'm reasonably happy with the range that I've seen on it. So here's what they look like. Now, my contribution to this project is different than most of my projects. I didn't actually do any programming for this project. You can put these things together yourself without my help at all. The problem is the radio module has pin spacing of 2 millimeters, which is not the standard 1/10 of an inch spacing that you're used to being able to plug into boards. And you can get adapter boards to work with that. The USB chip that I ended up using, which you can see here, is an FTDI rather close-spaced USB chip. It's not expensive, but the pin spacing on it is 1/2 a millimeter. Fortunately, you learned how to solder those this morning, so should be no problem for you at all. And the other thing is I put a 9-pin serial connector on the back of this board on the theory that if you had a Kenwood D700, you could just plug it into the radio. On the other hand, if you had a Kenwood D710, you could get an adapter cable and plug the adapter cable between the radio and this connector. And in fact, the standard Kenwood programming cable will work for this. If you've got Yaesu 817, 857, 897, that sort of series radio, you can get an adapter cable and plug it into that, but we have to make a couple of changes on the board because that's a TTL level signal. And if you have an ICOM radio, you can get an adapter cable and plug it into that. So some radios will need adapter cables, others will just work. So here's how this works. We have 2 modules here. One of them has a USB connector on it. You take the standard USB cable that came with your digital camera and plug that into a USB port on your computer. And the other is the serial module that goes in the radio. So what I'm going to do today is to demo it to show how it works. Now here's the thing, software, there is some software that I'm going to show you that allows you to do some configuration of these radios, but in terms of programming your own radio, you use whatever software you used before. The whole point of this is the computer thinks it's plugged into a serial cable, the radio thinks it's plugged into a serial cable, they don't know any better. So you just continue to use the same software that you did before. So here's my, my USB cable from my digital camera, and I'm going to plug this in, and it lights up so that you know that it's on. Now, this is using the FTDI chip, which uses the standard FTDI driver. You download those drivers and put them on your computer. You may already have them. Because this is, I think, the most common USB chip in serial USB converters, so an awful lot of people find that they've already got them on their computer. And if we go to the device manager here in Windows, and by the way, drivers for this chip exist for Mac OS too, and in addition to that, it's built into the Linux kernel, so if you the problem that you're going to have if you want to use an operating system other than Windows is finding software that programs your radio that's supported by those operating systems, not this particular device. Yeah, this is Vista. I'm getting rid of it soon. And you can see that we now have a USB port here. It's set up on COM1. You'll find that if you ever use one of these devices on a COM port, it'll treat that as taken even if it's not plugged in right now. And then it will keep incrementing up automatically. So if you use a lot of these, you have to get very used to readjusting the COM port number on it, which can be done right here from the device manager by clicking on Properties, going to Port Settings, and clicking Advanced. And here you can change it to anything you want. I use this same chip in another product that my company makes called TNCX, and so before I send these out, the wired and tested ones, and I'm now up to like COM 293 or something like that, and I readjust them all down to COM 1 and it works just fine. So let's start with Kenwood D710. Now here's the serial module. You'll notice I got a 9-volt battery connector on this. You could use the power supply that's powering the radio if you want, but here's a word of warning. If you do that, and if the ground connection comes off, so that the only thing that's connected to the power supply is the V plus wire, and if it's the same power supply that's powering the radio, it'll still work without a ground connection, but the ground return is going to be through the data line, or rather the ground on the data line. I'm a little bit worried because I don't know, and this thing draws like 300 milliamps. I mean, it's a 50 milliwatt radio. And I don't know for sure that the ground connection in all my radios is sufficient to handle that, though I'm reasonably certain that it is. But as the guy that's making these boards, I don't want users to come and blame me for having ruined their radio. So I'm recommending a 9-volt battery, and it's up to you to decide whether you want to take my advice or use the radio's power supply. So I've got a connector hooked up to the PC data input here on the D710. And I'll plug that in and connect power to it. Now, the fun way to do this demo, I had no idea how this hotel was going to be set up. The fun way to do this demo would have been to leave the radio in the car, because the parking lot's just over there. This should have no problem at all. This is, by the way, on the 2 gig ISM band, so it's the same band as Wi-Fi and everything else, so that in a really heavy RF environment, I guess conceivably there's a problem with this. Let me run the Kenwood 710 programming software here. And here's the setup for it. Those of you that have 710s have probably seen this. You'll notice the COM1 is the only serial port on this computer. I have it set up for 9600 baud. So let's read the data from the transceiver. Now, there's no physical connection between the radio and the computer here. These things could be 3 houses down the street. And there it goes. Now, if you're doing this normally at home at 19.2 kilobit or 115 kilobit, you probably are used to this running a little faster than it does at 9600. But consider this. You didn't take the computer to the car and you didn't bring the radio in the house. You just plugged the module in. That's all there was to it. This is the biggest lull in the presentation as we wait for this to finish. But even so, I don't think we're spending more than 60 seconds at this. I've tried this with, obviously, the D710, the D700. I've tried this with my Yaesu 817, which is the same as the 857 and the 897. I've tried this with my ICOM 706. Contrary to the views of my family, I don't actually own every radio. That's, but I've tried that with most of them. Okay, so that's what happens when you hook it up to a D710. I also have an 817 over here. Now, this is the level converter chip. I got to take it out. Oh, come on. There we go. And then I've got to reroute the signals around where that chip was. So I have 2 of these little jumpers on the board here to make that relatively easy to do. And now it's a TTL level device. So I'm going to plug it into the cable for the 817. And reconnect the battery. And now let's run some Yaesu 817 programming software. This software is designed not just to program, this software is designed to also do full rig control, which you can do over this link too. After all, the radio doesn't know it's not connected to a serial cable, and the computer doesn't know it's not connected to a serial cable. This is a program called FT817 Commander. I use it because it's free. And you'll see that it's listed as COM1 and 9600 baud. That's because that's the last thing it connected with. It's going to warn me. Usually it warns me that it could be doing this faster at a higher speed, but of course 9600 baud is what I've got this thing set for. So now I could, there's not much in the memories here, but let's read the memories out of the radio. And you'll be able to see down here, they are indeed reading over the same serial link. And I could just as easily be writing memories. After all, this is just data flying one way or the other. If I tune the radio, you can see that it is picking up the frequency change, and if you could actually see the display on the radio here, I could tune it here and you'd see it there as well. So it works very nicely with TTL level radios too. Now the one other thing I wanted to show you here was there's also software available direct from the Digi company for accessing this radio. And this is free software. It's very useful stuff. It's called X-CTU. Oh, Steve told me I was supposed to tell you what VSCX stands for. It's Virtual Serial Cable Extended. Actually, I did that to rhyme with TNCX, which is the other product I sell quite a bit of. Now, here is the XCTU software. One of the neat things about this is you could take a couple of these modules, hook them up to different computers, and you could walk around and check out range. So you can find out, without hooking it up to your radio and doing all this stuff, just how far you can get with the thing. Here, this computer has only one COM port hooked up to it, and if I push the test button, it does indeed find the radio modem there. So you'd run this software on two different computers. By the way, if you want to use a serial port for one of them, all you do is hook a null modem cable up to it. That works rather well. And then push the range test button on both of them. And if I had another one hooked up to yet another computer, we could put one on transmit, one on receive, and push the start button. And you'd begin to see good packets accumulating here on a graph. And then you could take the computer off and walk around with it, and eventually you would get to a point where you started to see a bad packet or two. That's when you know that you've reached the edge of the range. This thing also allows you to configure it. We're going to read the parameters that are currently on the radio by pushing the read button. Now, actually, this thing has provisions for extremely good security, including encryption. I just don't see why that would be necessary in worrying about programming radios. But, you know, if you're really anal about this, I suppose you could go that route. One thing you might want to do, though, is if you had multiple of these modules and plugged them into different radios and you just wanted to leave them there all the time and leave them on all the time, you could set them to be different addresses so that you could talk to one or talk to the other simply by changing these settings. And you'll see on here that we have settings for both source address, that's the address of the unit that this is currently hooked up to, and destination address. That's the address of the module you'd be talking to. This is a 16-bit number, which is set as 16 bits in the source address, and it's set as the low byte and the high byte in the destination address. If I just click on one of these, you can see that the value here is currently 0. You can, if you want, change that to anything you want, and you could have set different destination addresses for different radios, and actually be different source addresses for different radios, and then set the destination address here, depending on which one you wanted to talk to. So if you were indeed worried about somebody else coming up with a couple of these modules and driving up outside your house, all you have to do is change your whole system to some address other than 0, and you should be in business. Now, my contribution to this is developing the boards that do the interface. Other boards do exist. The SparkFun company that you heard about earlier this morning also makes USB and serial interface boards for these things. Theirs are significantly more expensive than the ones I sell. And there were two other problems, particularly on the serial side, that caused me to think that what we needed was a different board. One was it assumed that RS-232 was all you would ever want to talk, and that they needed to make no provision whatsoever for handling TTL level signals. And since their TTL to RS-232 chip is a fine-pitch surface mount device, in fact, circumventing that chip could be problematic. The second problem was, particularly for people that happen to own radios like D700s that have 9-pin D-sub connectors on the back of them. They put the power connector and the 9-pin D-sub connector on the same side of the board, so that if you plug it into the radio, you no longer have access to power unless you wire in another connector, and I thought that was a bit of a drawback as well. So Coastal Chipworks has started selling pairs of these boards that are available as modules. I should mention, by the way, that these XP Pro radios, you'll notice the little whip antenna on it. I think that's kind of cute. They actually have 3 antenna configurations for this, and you can buy radio modules from companies like Mouser Electronics that have any of the 3 on them. One is this whip antenna that I thought was a really good compromise between size and bulk. A second one is an on-board antenna that's like a wire loop that's just on the board, so nothing sticks up, but the range on that isn't going to be quite as good. And the third possibility is, yes, you can get a standard antenna connector built into the thing, so if you need to hook that 3-foot dish up to it. I didn't say it was legal, I just said you could do it. You can go, knock yourself out and really go crazy with it if you want to. All 3 of those radios can be used with the VSCX boards that I have available. And so that's my presentation. Any questions?
Have you considered having 2 connectors on your little board, one being a genuine 9-pin RS-232 and another one being a mini DIN connector for the TTL levels, and you plug in the right cable for the right radio, and you're done.
Yeah, you could do that. You'd have to have a bigger board then.
Oh. Whatever.
And I kind of like the idea of being able to simply plug this directly into the back of the radios like the D700, so that I can show you a picture of that. It's a neat installation. That's the board in the D700. My inclination would be just plug it in there and leave it permanently connected.
Is the 9600 baud high side, or I guess 2 questions. Is that the max baud rate you can go, or is the max baud rate some semi-dependent on distance you want to try and get?
No, I don't think it's related to distance, but let me show you in the XCTU software.
Because you can never go fast enough.
One of the parameters that you can adjust is the baud rate of this module. The reason I've got this locked for the user software at 9600 is that I've got these modules set up to communicate at 9600 baud. Now, there is a bit of buffer on the chip, and so the question is how this thing will go much faster, like 115 kilobit, I believe. But if you're doing what we're doing with radios, which is downloading a large amount of data, getting that throughput then over the air and into the connection, I'm trying to hit a baud rate that makes sure that I'll never overrun a buffer at any point along this way. And 9600 works great. I tried bumping it up a bit, and as yet I haven't had a lot. I only tried that once, and I haven't experimented with it in detail, but it did not work well the one time I tried it. Now, what I really should do is to bump it up and then use terminal software on either side and transmit a file and watch the file go through and see what's really going on. These devices also support hardware handshaking. In fact, that's what's going on with the Kenwood D710, is it requires hardware handshaking. Now, it's not hardware handshaking end-to-end. It's hardware handshaking between the radio module and the radio. So it's different than what you. It's not like it's implementing the CTS RTS lines over the air. Instead, it simulates those on each side with the radio. So you still have to worry about the buffer size in the XB radio itself. And I think if you had really bursty data, which you might have if it was a radio control program, if I were trying to do remote control of the 817, for example, doing this, I think I probably could get away with this at a higher speed, and then it would adjust much more quickly on the screen when I turned the dial on the radio. But I envisioned this as mostly memory management, and it's just pushing out large quantities of data, and I want to make sure the pipe will handle it.
I was just wondering about the interference and possible contaminant, or what do you want to call it, interference issues with the with the Zigbee and the 2.4 gigahertz band, and possibly how that your encryption or decryption would circumvent that.
I don't think encryption is going to do it, but you'll also notice on this, the first parameter here on the XCTU thing is channel selection. And so if, for example, you're discovering that this is interfering with your Wi-Fi at home or other devices like that, most of the Wi-Fi stuff you can move the channel to, or you could change this channel and you should be able to. I've not run into an environment where that's been a problem yet. And I've been particularly worried about, I'm demoing this here, and I suspect there's a lot of Wi-Fi here. I demoed it at Hamcom, and I'm sure that place was just lousy with it, and haven't really run into problems yet. More information, including you can download the manual for this thing, can be found at www.vsc-x.com. And I actually brought 5 sets of these, so if anybody's just dying to have one, they are available for $110 a pair. Now that's not kit. You get the modules and they're ready to go wired and tested. Thank you.
Thank you, John.